Half a day students, today's lesson deals with division of real numbers. This is section 2.7 in your book. Some words you'll be hearing are quotient and reciprocal. A quotient is just the answer in division. So I was to divide 10 and 2, 10 divided by 2, the answer is 5. So our quotient of 10 and 2 is 5. Reciprocal we'll go through in the next slide. So when talking about reciprocals, there's a really important property of it. Just states that the product of a number and its reciprocal is 1. To get the reciprocal of a number that's not a fraction, when we're thinking about a, so I'll say, okay, if my a is 4, the reciprocal of a when a is not equal to 0 is 1 over a. So the reciprocal of 4 is 1 over 4. This works the same for variables and negative numbers. So if I had negative 2, its reciprocal is negative, you keep it on the outside, 1 over 2. Reciprocal of x is 1 over x. So if you're actually given a fraction where a is divided by b, we'll write it as this, a over b. Its reciprocal is b over a. You just flip it. Okay, and this is actually the same for the other way around, and I'll show you an example. But if I had like 2 over 5, the reciprocal of 2 over 5 is 5 over 2. It works for negatives as well. Negative 3 over 7, reciprocal is negative 7 over 3. Notice that the sign does not change, it's only flipped. Okay, and this works too, it's both ways. So if I was to do 4 again, I just imagine it as a fraction. 4 is the same as 4 over 1. Flipping that is going to be 1 over 4. And it's true that each of these, when I was to if I was to multiply them, it would be 1, because look, let's try this 2 over 5 and 5 over 2. Multiplying these two, when we multiply fractions, we just multiply across. 2 times 5 is 10. 5 times 2 is 10. 10 over 10 is just 1. So all of these, any number multiplied it by its reciprocal is positive 1. But as long as you know how to find the reciprocal, you should be good. Looking at the division rule, to divide a number by a non-zero number b, multiply a by the reciprocal of b. So I'll write it out like this, a divided by b, or a over b, right, is equal to a times 1 over b. So I know you already know how to divide, but it's kind of just explaining that division is not really a different operation from multiplication. It's just multiplying by a reciprocal. So it comes out to the same thing if you're just to divide it straight, but it's a good thing to know in the future. Okay, so example 1. This rule comes in handy, especially when we're dealing with fractions, right? Because if b is a fraction, I would just flip it. Positive or negative. Division, again, is just pretty much the same as multiplication. So if I did a positive over a positive or a negative over a negative, it's going to be positive, right? Same signs, positive, positive over negative, or negative over positive, that's going to be negative. So same signs, positive, different signs is going to be negative. Example 1, 10 divided by negative 2. So this is really easy. I already know it's going to be negative because I have a positive divided by a negative. And again, this is something that's very easy for us to divide. I already know the answer is going to be negative 5, but just for the sake of this example, I'm going to write it as using the rule. So I have 10 times the reciprocal of negative 2. So the reciprocal of negative 2 is negative 1/2. From there, multiplying that, half of 10 is going to be 5, right? So we have negative 5. Looking at this next one, negative 39 divided by negative 4 and 1/3. And again, with this math class, I don't want to be seeing mixed numbers anymore. I want to be seeing improper fractions. So first thing I'm going to do is actually change this to an improper fraction. I'm rewriting negative 39 divided by, so what I'm going to do is multiply 3 times 4, so I'll get 12, plus 1. 3 times 4 plus 1 is going to be 13 over 3, and this was a negative, right? Negative 13 over 3. Then I'll apply the rule where we multiply by the reciprocal, so we have negative 39. I'll actually write it as a negative 39 over 1 to make it a fraction, times negative 3 over 13. I flipped it. And it doesn't matter where you put the negative sign. Some people put it in the front, some people put it in the numerator. It doesn't matter where the negative sign is. It just matters that that term is negative. From here, I'll actually multiply across. Negative 39 times 3. I'll do on the side here, 39 times 3, we have 27. 3 times 3 is 9, plus 2 is 11. 117. And I have a negative times a negative, so it becomes positive. Over 1 times 13, which is 13. This is actually easy, or this is simplifiable. This is actually going to come out to just 9. I keep that using long division or just trying to multiply 13 by different numbers to see what you get. Looking at letter C, we have negative 1/3 divided by 4. I'm going to rewrite this the long way. So we have negative 1 over 3 divided by 4. Rewrite it using the multiplication. So we have negative 1 over 3 times the reciprocal of 4. If it's just number, I'm doing 1 over that number. 1 over 4. Simplifying here, let me just put a little border so I don't go into that one. Negative 1 over, multiplying across, is 12. Okay, looking at this last one, I now have 1 divided by negative 3 over 4. So this is 1 divided by negative 3 over 4. I'll rewrite it again. 1 times the reciprocal of the second, negative 4 over 3. Multiplying across, I'll actually rewrite this to be 1 over 1. Multiplying across, 1 times, I know it's going to be negative because I have negative times positive, negative. 1 times 4 is 4. 1 times 3 is 3. And actually I could have just said, okay, 1 times anything is just going to be the same number. So once I saw this 1 times that, I would just take that number automatically. So negative 4 over 3. If you're unsure about your answer, you can always multiply your quotient by your divisor, the number that you divide it by. So I'd multiply negative 4 over 3 by negative 3 over 4, and I would get 1. Moving on to our second example, use the distributive property to simplify. So there's one way to do this. I'm going to show you the certain way that the book does, just so we can see that they're actually using, again, the distributive property. So, okay, rewriting this as 32x minus 8 times, divided by 4. Using the property that we just used, I'll rewrite this as 32x minus 8 in parentheses, times the reciprocal, which is 1 over 4. From there, I could actually distribute to each of these in the inside, right? I have one number in the outside, I have 2 terms in the inside. Distributing to each of these, it's 32. So I'll have 1 over 4 times 32x plus 1 over 4 times negative 8. And when I'm multiplying these ones, I'm going to imagine it as a fraction, right? 1 times 32x over, multiplying across, I have 4. This next term, 1 over 4 times negative 8, I have a positive times a negative, it'll become negative. 1 over 4 times negative 8 over 1. So 1 times 8 is going to be 8 over 4, which is actually equal to, simplifying 32 and 4, they're both divisible by 4. This becomes 8x. 8 over 4, you know, is 2. Another way to do this would be actually to just separate this into two different terms. We have 32x over 4 minus 8 over 4, and then simplifying from there, which is essentially the same thing that we're doing here. This is just really showing us the process. But now that I know this, I can change this to be dividing by 4. I know is the same as multiplying by 1 over 4. I can go straight to distributing it to each side, or dividing each of these by 4. Example 3, evaluating an expression. We're evaluating the expressions when a is -2 and b is -3. First thing I need to do whenever evaluating a variable expression, I'm going to substitute. So this is equal to -2 times -2, which is a, over -2 plus -3. From here, I'll use PEMDAS to simplify. And again, whenever I have a division sign, the division line in the middle, that's actually its own grouping symbol pretty much. So I'll do whatever's on the top and whatever's on the bottom, and then simplify from there. So -2 times -2 is +4. -2 plus -3. Be careful with these when it's multiplication or addition, subtraction. Be careful, okay? So we're adding now these two, which is going to be -5. The last step would be to check if you can simplify. 4 and 5 have nothing in common, right? So that's actually my final answer. Again, we're leaving everything as a fraction. And you could put it as 4 over -5. If you put it as -4 over 5, that's fine too. If you have it on the side, it's also correct. So they all mean the same thing. A lot of people tend to prefer it on this side. Doesn't matter. Looking at letter B, a squared minus 4 over b. First step, plug them in. -2 in parentheses squared minus 4 over -3. PEMDAS, parentheses, exponent. So I'm doing each side, but I'll do the exponents first. -2 times -2, that's -2 squared, right? -2 times -2 is +4. Minus 4 over -3. 4 minus 4 becomes 0 over -3. 0 divided by anything is going to be 0. That's fine. Looking at this last one now, plugging in our variables, we have -2 over 3 plus -3. So simplifying each side, -2 over 3 plus -3 comes out to 0. So there's one thing that we can never, ever do in math, and that is divide by 0. I'm sure you guys have heard of this before. Everyone has. It's the most important rule. You cannot divide something by nothing. So this is undefined. Once you hit, when you're evaluating, once you hit a dividing by 0, we just stop working from there and you write undefined, because it's impossible. Example 4 deals with finding velocity. So velocity is actually very similar to speed. There's one big difference between velocity and speed. So whenever you say the speed of something, you're dealing with positive numbers, right? Oh, the car is going 40 miles per hour. He's running at 5 feet per second. Okay, so something like this. Velocity, on the other hand, could be either positive or negative. And this positive or negative indicates the direction that something is moving. When we're talking about the height of a hot air balloon, we're saying it goes up and down. So a positive velocity would indicate that it's moving upwards, whereas a negative velocity would indicate that it's going down. And some words that we like to use are ascend and descend, right? So in this problem, we're descending at 500 feet in 40 seconds. To find the velocity, my formula is actually given, where velocity is equal to displacement over time. So in this one, I'll say my displacement is not just 500 feet, right? It says it's descending, so I'm going down. I'm going to have a negative velocity. I'm going to have a negative displacement. So my displacement is actually going to be negative 500 because it's going down 500 feet, descending. Time is 40 seconds. We're always going to be careful with time because we want to make sure that we're in the correct units. So setting up my equation, V is equal to displacement, which is negative 500, over time, which is 40. When we're dividing, and I have zeros on the end of each, I can actually have one of them cancel the other. Basically, I'm dividing each of them by 10, right? So I can figure this out on the side, negative 50 divided by 4. Dividing here, I know it's going to be negative, divided by positive is negative. 1, I have 4, 10, carry the 0 down. 10 divided by 4 is 8. Oops, sorry. 10 divided by 4 is 2, times 4, 8. We have remainder 2, so I'm going to add a decimal and another number, another 0. 20 divided by 4 becomes 5. From there, 20. 0, so we're good. So negative 12.5 is my velocity. Again, it's a word problem, so I'm going to represent it in a sentence, and I need to answer in words. So if you put negative 12.5, that's not going to be accepted. You need to have a unit, right? So my velocity is negative 12.5. We have feet per second. And that is the final answer. So when you're given problems like these in Algebra 1, it's really just to prepare you for later on, because this is actually something that you would do in physics or calculus. So we're getting us ready, and we're seeing the connection between what we're learning now and what we'll be dealing with later on. Now on to our last example, finding the domain of a function. So domain of a function are the x values that you can put in. And for this, I'm actually going to keep in mind what's the one thing that I could not do in math, right? We have to exclude any values that make my denominator 0. So anything that's dividing by 0 is impossible. So the x values that make my denominator 0 are ones I'm going to exclude. So to do this, to find the number that I can, what I'm actually going to do is take my denominator, 1 minus x. I want to find where it actually equals to 0. So what I'm going to do is 1 minus x equals 0 and solve for x. You can ask yourself, what number subtracted from 1 is equal to 0? So I know I can get 0 by subtracting 1 from 1, right? So I can say, okay, 1 minus 1 is equal to 0. Since 1 minus x equals 0, when x is equal to 1, 1 is not in the domain. And we know that this is because we cannot divide by 0. Any other number will work with this. So we say that our domain is all real numbers except 1. One way you can write it, we can say x is not equal to 1. So that's it for this section. I know it was a long one, but we're really just building off of what you learned in middle school and connecting it to how we're going to be using it in higher math, right? Dealing more with fractions and polynomials and functions. Good job. Do your work. Have a good day.